Look at this, same eval set, same docs. Vanilla RAG hit 62%, hybrid plus rerank hit 91%. You know that feeling. Your RAG is up, embeddings flowing, ChromaDB humming, but the model keeps missing answers sitting right there in your docs. So you swap to a bigger model and crack up top K, but nothing helps. Because honestly, the bug isn't the LLM, it's retrieval. We're fixing it with two pieces. Alright, so hybrid search is basically just two retrievers running side by side. BM52 is your keyword guy. It catches exact stuff, product codes, function names, weird identifiers. Vectors handle meaning, paraphrases and synonyms. We mash both result sets together, then a reranker comes in and rescores the top candidates. That last step is where the magic happens. The reranker looks at the query and the chunk together, so it just knows what's actually relevant. Alright, 3 stages. Two retrievers grab candidates in parallel, we merge them with reciprocal rank fusion, and the reranker takes the top 50 and trims it down to 5. Notice the reranker only sees a small set, so latency doesn't blow up. We are using rank BM25, ChromaDB and Cohere Rerank 3. And if you don't want to pay for an API, just swap in BGE Reranker v2 locally. It's basically the same thing. So let's get this set up. We need rank BM24 for keyword search, ChromaDB for the vector store, Cohere for the reranker, and a text splitter from our LangChain to chunk our docs. One install command handles all of it. After that, drop your Cohere API key into an environment variable so you don't have to hard code it anywhere. Next we create a file called hybridrank.py. Let's handle imports and clients. Notice we're spinning up Chroma in memory mode for the tutorial. In production, you would point this at a persisted directory. We're also setting up mini-LM as our embedding model. It's small, fast and runs locally, so no openai key needed for embeddings. The Cohere client is the only thing that needs a real API key here. Before we continue with the implementation, let's create a new folder and call it docs. Inside the docs folder, we create a new file called corpus.txt. This will be our knowledge base. So back to the code. This is where we prep our knowledge base. We read the corpus file, then run it through the LangChain's recursive splitter. Chunk size is 500 characters with an overlap of 50. The overlap matters because BM25 in particular hates context cuts mid-sentence. If a keyword sits right on a boundary, you can lose it entirely in retrieval. This recursive splitter tries to break on paragraph and sentence boundaries first, which keeps chunk semantically clean. You can point this at whatever text file you want as your knowledge base. Now we build both indexes side by side. The Chroma collection embeds chunks automatically using mini-LM and stores them with sequential IDs. For BM25, we tokenize each chunk by lowercasing and splitting on whitespace. That is the most basic tokenization you can do. You can swap in a proper tokenizer like spaCy if your corpus has lots of punctuation or compound words. The key thing to notice is that both indexes hold the same chunks in the same order. That makes fusion trivial later. We just need the ranked indexes from each side and not the actual text. And now this is the fusion step. Reciprocal rank fusion looks complicated, but the math is that simple. For every doc in every ranking, we add 1 over k plus its rank position. Then we sort by total score. The k constant is 60, which is the standard value from the original paper. Notice we don't care about the raw scores from BM25 or the cuisine similarity from Chroma. We only use the rank positions. That is exactly why RRF works so well. It normalizes wildly different scoring scales into one consistent signal. Alright, this is the whole pipeline in one function. We grab the top 50 from BM25 and the top 50 from vectors. Then we fuse them with RRF to get a single ranked list of candidates. Now here is where the reranker earns its keep. We hand those candidates to Cohere Rerank, which uses a cross-encoder to score each chunk against the query directly. The model returns the final top 5. That last step is the precision pass. Cuisine similarity is good at narrowing 50,000 chunks down to 50. The reranker is good at picking the right 5 out of those 50. And now let's put the query that we know has a specific answer somewhere in our corpus and run the file. Let's fire the hybridrank.py and see what happens. Let's now inspect the output. You can see the 5 results returned to us. The most relevant one, as we can see, is the JWT configuration path. That really makes sense based on our question. And down below you can see less relevant but still useful answers. Let's now change the question. Let's ask something like how to handle errors. And let's run it again. This time you can see that on first place it returned the error handling block and then everything else. You can see how smart it is at identifying the correct data in your corpus file. Alright, look at what you've got now. A retrieval stack that actually pulls the right chunks. BM25 picks up the keyword stuff vector search misses, and the reranker just cleans up the final ordering before anything hits your LLM. So what is the next step? Take this and plug it into a rack app you have already built. Run your own eval, and honestly, if you don't have an eval set yet, just build a tiny one. 20 questions is enough. It changes how you think about retrieval. If you want more stuff like this, hit subscribe. I'll catch you in the next one.